Hello friends, welcome to our today's video lecture. In previous classes we have studied about relation, what is relation, and we have also studied about various types of relation. Let us recall. We have discussed about empty relation, universal relation, and a pair of three relations which are reflexive relation, which are transitive relation, which are symmetric relation. You know what are these? A relation is said to be reflexive if each element of set A is related to itself. What is symmetric relation? A relation R is said to be symmetric relation if for elements A and B in set, if A is related to B, then B must be related with A. What is transitive relation? Transitive relation says if there are three elements in a set, 1, 2 and 3. So if element A is related to B and element B is related to C, then it should conclude that element A is related to C. This is transitivity. And if a relation is reflexive, symmetric and transitive, then such relation is called equivalence relation. We are clear with this. Okay. Now, in previous video, we were doing the exercise 1.1 of NCERT book. This is a question and we will do this a question using geogebra. I hope आप लोग जानते होंगे geogebra क्या है, नहीं जानते तो ग्राफिंग सॉफ्टवेयर है जिसको आप अपने फोन के अंदर या फिर अपने लैपटॉप के अंदर यूज कर सकते हैं। जियोजेब्रा में चलते हैं और उसको प्ले करते हैं। मैं आपको बताता हूँ। 12th क्वेश्चन पर जाने से पहले हम लोग क्या करते हैं, हम लोग जियोजेब्रा में इस क्वेश्चन को समझते हैं। एक बार पहले हम जरा क्वेश्चन पढ़ लेते हैं क्या है, उसके बाद हम उस पर चलेंगे। अब जरा क्वेश्चन देखिए ध्यान से। क्वेश्चन है शो दैट द रिलेशन आर इन अ सेट ए ऑफ पॉइंट्स इन प्लेन। सेट में क्या है मेरे, प्लेन के अंदर के सारे पॉइंट्स हैं। गिवन बाय रिलेशन क्या दिया, पी क्यू। Distance of the point P from the origin is same as the distance of point Q from the origin। यानी कि दो पॉइंट्स मेरे पास में रिलेटेड होंगे अगर पहले पॉइंट की ओरिजिन से डिस्टेंस और सेकंड पॉइंट की ओरिजिन से डिस्टेंस इज सेम। टू पॉइंट्स आर रिलेटेड if their distance from origin is same। Clear? Keep it in your mind, then we will do this in GeoGebra. We will see some animations. Okay, and I am supposed to prove that this relation is equivalence relation. Okay, then we will do the second part later. Now let's go to the GeoGebra. Okay, here we come. Now we will see what I am doing. You will see are seeing a GeoGebra graphics, and let me draw something for you. Here first of all I will start with the origin. You can see the origin here. This is the origin. Okay, and in this origin then he said there must be a point which is equidistant. I took a point P, and this is you can take any point, you can take any point anywhere in the space, and I drawn the distance. Their distance is 8.49. if I will increase, the distance will increase, and if I will came it closer to origin, the distance will decrease. Okay, I take any point anywhere on the. Okay, now we will check the reflexiveness for this. Condition क्या थी relation की कि a point related to B if they are equidistant from origin. Now distance of P is 7.94. Let me make it integer term. Yes, now distance of P from O is origin is 8, and distance of P is from origin is 8. So point P is equidistant from origin and itself, है ना? P is related to itself. P comma P belongs to R. So I can say this relation of being equidistant from origin is रिफ्लेक्सिव। समझ गए ना? पहला पॉइंट, अगर कोई पॉइंट कुछ डिस्टेंस पर है ओरिजिन से, देन दूसरा पॉइंट अगर मैं खुद ही उसको लूं तो इट इज इक्विडिस्टेंट फ्रॉम ओरिजिन, तो उसकी डिस्टेंस उतनी रहेगी, तो इट इज रिलेटेड टू इटसेल्फ। ओके, नाउ लेट्स टॉक अबाउट सेकंड पॉइंट। अब मैंने एक दूसरा पॉइंट लिया, दिस इज Q. नाउ व्हाट इज द कंडीशन फॉर दैट? पॉइंट सारे वो हैं जो है ना रिलेटेड होना चाहिए. सो इफ द डिस्टेंस बिटवीन distance of P from origin is 8, then the distance of Q must also be 8. If I increase the distance of P, the distance of Q must increase. If I increase, I am increasing the distance of P, then this distance of Q is also increasing. So P is related to Q. I hope this is clear. P is related to Q. Now for symmetry, if P is related to Q, then Q must be related to P. So you will see if I increase the if distance of P is equal to distance of Q, I can also say that distance of Q is equal to distance of P. So if P comma Q belongs to R, then Q comma P also belongs to R. I hope I am clear. So this relation of being equidistant from origin is symmetric relation. Now for transitivity I need 3 points. So I drawn one more point Q1, है ना? And what is the condition? If P is related to Q, distance of P from origin equal to distance of Q from origin. Second required condition, Q is related to Q1. I hope you can see this, and you can see this. If P is related to Q, then Q, and second required condition, Q is related to Q1. It means the distance of Q is equal to the distance of Q1. Then you can say that if P is related to Q, their distance is same from Q. Q is related to Q1, their distance from origin is same. You can also say that P is related to Q1, first element related to third element. So because their distance of P from origin is equal to the distance of Q1 from origin. पहले वाला दूसरे से रिलेटेड है, डिस्टेंस इक्वल. दूसरे वाला तीसरे से रिलेटेड है, डिस्टेंस इक्वल. सो यू कैन से पहले वाला थर्ड वाले से रिलेटेड है because their distance from origin is also equal. Okay, so this relation is transitive too. Now this is reflexive, it is related to itself. This is symmetric, P related to Q and Q related to P. And this is also transitive, P related to Q, Q related to Q1, then P related to Q1. Okay, this is clear. So we let's go back to our question. And what question was? Question was saying that if let me repeat the question. Show that the relation R in the set A of points in a place given by R. This is 11th question of your exercise. P comma Q such that distance of point P from the origin is same as the distance of the point Q from the origin. है ना? Is a equivalence relation. हमें प्रूव करना था कि equivalence relation है. So we proved that this is reflexive, this is symmetric, and this is transitive. Hence, this relation is equivalence. Now let's see the second part. What it says. Further, show that the set of all points related to a point P is a circle passing through P with origin as center. वो कह रहा है आप जो भी points plane के अंदर P से related है, P से related होने का मतलब क्या है? They are equidistant from origin. उनकी origin से उतनी दूरी है जितनी P की है. ऐसे सारे points को अगर आप collect कर लोगे तो आपके पास क्या बन जाएगा? You will get a circle which is passing through P and whose center is origin. Now let's see again this in our geogebra. But it is there. I take some other points Q2 which is also equidistant 6.37. I take another point Q3 which is also equidistant, and if I take many other points and you match all the points, आप इन सबको मिला दो तो आपके पास क्या आएगा? You will see that you got a circle, और वो circle passes through P and origin is O. And if I change the P, you will see that if I change P, तो उनकी जो distance है सबकी, because they are equivalence relation, their difference will relate, they are related, so the distance from origin is same. Now we will see the power of equivalence relation. If I change only one point P, you will see that it always remains a circle. It always remains a circle. Only the distance will change because they are equidistant. This relation is equivalence. This is the meaning of equivalence relation. If I change P only, you will see all other points will behave in the same pattern. This is equality, equivalence relation, and this shape always remains a circle. The matching, the connecting dots of the curve connecting these dots will always remain a circle. This is the power, this is the benefit of equivalence relation. Okay, now let's see, let's get back to our further questions. Okay, now let's go. This is 11th question done. I hope you understood, and if you have any query we can ask in comments. Now let's do the 12th question. 12th question कह रहा है, show that the relation R defined in the set A of all triangles as this, है ना, सारे ट्राइंगल्स किसी प्लेन के अंदर हो सकते हैं वो, एंड रिलेशन इज T1, T2 सच दैट T1 इज सिमिलर टू T2, T1 सिमिलर है T2 से, ऐसे रिलेशन मैंने डिफाइन किया. मुझे बताना है कि रिलेशन जो है ये एक इक्विवेलेंस रिलेशन है. कैसे बताऊंगा? पहले बात करते हैं सिमिलरिटी क्या मतलब है. टू ट्राइंगल्स आर सिमिलर इफ देयर साइड्स corresponding sides are in proportion, है ना, AB upon PQ and they are in form. Now he says given set all triangles in my plane, so I drawn some triangles, है ना, they can be equivalent, they can be isosceles triangle, they can be right angle triangle, any triangle, equilateral triangle, any triangle, all are in my set. Now let's check for reflexive. For that you can take any element. I took this blue triangle, and for reflexive it must be related to itself, it must be similar to itself. So every triangle is similar to itself, very obvious, so this relation is reflexive. Now for symmetry, if blue is similar to red, then red will be similar to blue. Okay, you can watch this carefully. This relation is also symmetric. Now if I am talking about 3, for transitivity I need 3. So if first is related to, you can see first is similar to second, है ना, these are in proportion, and second is similar to third, their sides are also in proportion. Can you say first one is similar to third? Yes, obviously you can say they are, the relation of similarity is a transitive relation. Okay, now this relation of similarity, two triangles are similar, this is reflexive, symmetric and transitive, and collectively I can say this is equivalence relation, and this is what I am supposed to prove. Okay, so I prove this relation is equivalence relation. Okay, done. And the relation T1 T2 such that T1 is similar to T2. This is, now let's see the further second part. It is saying consider 3 triangles. It is saying that consider 3 triangles. Let's read this. It is saying that consider 3 triangles, T1 with size 3, 4, 5, T2 with size 5, 12, 13, and T3 with size 6, 8 and 10. Which triangles among T1, T2 and T3 are related? कौन से उनमें से related है? तो इसको जरा हम करते हैं, और मैं करता हूँ इसको पहले ग्रिड्स में कन्वर्ट कर लेता हूँ, और अब मैं इसमें जो है ट्राइंगल्स ड्रॉ कर लेते हैं. ये हमारे पास में ट्राइंगल हो गया, और मैंने 3, 4, 5 पहला ट्राइंगल बनाया. देन आई विल ड्रॉ सेकंड ट्राइंगल विच इज 5, and second side is it's 12, third side is 13. Then I will draw a third triangle with given sides, and he gave that the third triangle is 6, and second side is 8, and third side is 10. Now what he is asking, उसने कहा है कि ये इनमें से कौन से आपस में related है. Now you will see for 3, 5, 4 and 5. Sorry, I think there is some. Okay, wait a second. Yes. So yes, we were here. We have drawn the 3 sets. and we are supposing that we were checking that this relation is they are related to or not. So for relation is defined by the T1 must be similar to T2. So I will check for red and yellow, they are similar to each other, no or no. For this their sides must be in proportion. So I checked 3 upon 5, 3 upon 5, 4 upon 12 and 5 over 13. These are in proportion or not. You can see that these are not in proportion. So these are not related to each other. Now let's check for red and now let's check for blue and yellow first. So 6, 8 and 10 and 5, 12, 13. They are also not in proportion. So they are also not related to each other. Now for red and blue, 3, 4, 5, 6, 8, 10. You can see they are in proportion. So hence I will say that these red triangle and blue triangle are similar to each other. Hence they are, again I will say they are related to each other. They are similar and related to. So this is the way T1 and T3 are related. Okay. Now let's go for the 13th question. Show that the relation are defined in the set A of all polygons. The defined in the set A of all polygons as P equals to P1, P2. P1, P2 have same number of sides. Is an equivalence relation. फिर मैंने क्या किया, मुझे सारे उसने का सेट के अंदर सारे पॉलीगन्स जितने हो सकते हैं वो सब आते हैं, और रिलेशन क्या है, टू polygons are related if they have equal number of sides. So I'm drawing my set. There can be triangles, squares, pentagons, hexagons, and so there can be many other polygons. Now again, for checking the equivalence relation, you can see that they are reflexive or not. So for checking this, a triangle is related to itself, a square is related to itself because they have equal number of sides. And similarly, pentagons are related to pentagons because they have same number of sides. So this is reflexive. Now symmetric. If I take any two objects from that, if one is related to red is related to yellow, equal number of sides, then yellow is related to red, equal number of sides. Okay. Now for transitivity, if I take I'll say again some polygons which are like okay, a square, second polygon with 4 sides and third polygon with 4 sides. If you say first is related to second, I'll say first is related to, I will check for first and second. You will see their number of sides is equal. So blue is related to yellow. Now I will say check it for second and third. You will see the number of sides in yellow is related to number of sides in green. So yellow is related to green. So first is related to second and second is related to third. Can I say that first is related to second? Yes. Number of sides here is 4, number of sides in green is 4. So they are also related to each other. So you can say S1 is related to S2, S2 is related to S3, hence you can combine first and third. S1 is related to S3, hence this is reflexive, symmetric and transitive. So I can say that if all three properties are satisfied, then my relation is equivalence, because equivalence relation is made up of all these three properties. Okay, I hope this is clear. Okay. Now let's go further and second part. What it is saying? It is saying कि मुझे वो सारे elements बताइए which are related to a triangle with side 3, 4 and 5. अब कौन से polygon इससे related होंगे? Condition क्या है? Number of sides should be 3. So इसके अंदर 3 है number of side, तो बाकी सारे triangles के अंदर भी तो number of sides 3 होंगी. So if you check this with any polygon which have 3 number of sides, that is triangle, then it will be related to them. And if you relate it with a square, can you see that this is related with a square? It has 3 sides, a square have 4 sides. So this is not related to square. Is it related with pentagons? No, it has 3 sides and pentagon have 5 sides. So a triangle with side 3, 4, 5. Measures length of side are not important. Number of side is important in our this present context, present case. So number of side is 3. So all polygons with 3 sides will be related to it. And what are all those polygons? All triangles in plane are related to itself. So this is the answer of second part of our question. Okay, now let's go for the 14th question says let L be the set of all lines in xy plane and R is the relation of L defined by L1 L2. L1 is parallel to L2. Show that R is an equivalence relation. Find the set of all lines related to the line y equal to 2x plus 3. Now we will do this in GeoGebra. Okay, and before going to 15th question, before doing this 15th question, let's do the this part in GeoGebra. So let's go back to our GeoGebra before starting 15th question. Here we go. Now I am starting a new file here. Don't save this and now see what I am doing here. उसने कहा कि आपके पास जितनी भी प्लेन के अंदर लाइंस हो सकती हैं वो हमें बना लेनी है. ठीक है, तो लाइन बना लेते हैं. कितनी हो सकती है? बहुत सारी लाइंस हो सकती हैं. ओके, सो आई एम मेकिंग अ लाइन. Here I made a line. Okay, now this is my line. You can see that if I zoom it, this is a line, this of infinite length. Now what I am doing is I can move it anywhere. Okay, I can move it anywhere. I can make any other line out of it. So if you see the relation is a line is parallel to itself or not, है ना. मुझे देखने को line खुद से parallel है कि नहीं. For reflexive, it must be a line should be related to itself. Can you say this line is parallel to itself? Being parallel means in the same direction. Two lines are parallel when they are going in same direction, because if they are not in same direction, they will intersect somewhere. So the property we study, two lines are parallel if they don't intersect. It actually means that two lines are parallel if they're going in same direction. So this line is going in same direction with itself. So this line is related to itself. Okay, now I am drawing a parallel line. Okay, now I am going to draw a parallel line. If here, wait a second, I will draw a parallel line. This is point. And then select. So I draw this second line. You will see that the second line, let me give this, change its color, and let me make it red so that it is visible. Okay, now you will see I have two lines, this blue and this red. Now for you will see for symmetry, if red line is parallel to blue, can you say blue line is parallel to red? Yes, obviously we can say if this red is related to blue, then blue is related to red. The symmetric relation satisfy. I can move anywhere, but if this is related parallel to this, then blue will be parallel to this. Now again I will make for transit checking. So this relation is reflexive and symmetric. Now for checking the transitivity, I will make another line, and this is parallel to this. Now let me change the color of this, and I am making this green so that it is visible. Now for transitivity, you will see if red is parallel to blue and green is parallel to red, पहले वाला दूसरे से रिलेटेड है, दूसरे वाला तीसरे से रिलेटेड है. आई एम टेलिंग इट टू यू. Can you definitely say that blue is parallel to green? Means first one should be parallel to third one. Can you definitely say? Yes, I can definitely say that first one is related to थर्ड. पहले वाला तीसरे के भी पैरेलल होगा ना, एक लाइन दूसरे के पैरेलल, दूसरी तीसरे के, so first and third are parallel to each other. Hence this relation is equivalence relation. Now let's go to our question, back to our question. What it is saying? It is saying that let me get back somewhere, and where is our question? This is 15 and here is our 14th question. 14th question says that let L be the set of all lines in xy plane and R be the relation in L defined as R equal to L1 comma L2 such that L1 is parallel to L2. Show that R is an equivalence relation. So we have proved that this relation is an equivalence relation. Now it is asking find the set of all lines related to the line y equals to 2x plus 4. वो कह रहा है कि सारी लाइंस फाइंड कीजिए जो y इक्वल टू 2x plus 4 के पैरेलल है ना? उस सेट बताइए कौन सी लाइन उसके पैरेलल होंगी. तो अब इसको फिर से जियोजेब्रा में चेक करते हैं. एक बार आइए जियोजेब्रा में चलते हैं अब हम फिर से to see the. Now let me remove this and make a new one. Okay, that's it. Now he is asking for y equals to 2x plus 4. He is talking about this line. So I drawn this line. You can see it is visible here. This is visible here. He is talking about y equals to 2x plus 4. So you know that if y equals to 2x plus 4, it plus 4 means it should cut y-axis at 4. So this is my line y-x plus 4. Let's write its name over here. So label setting and value. Okay. So you will see that this is y equals to 2x plus, this is y equals to 2x plus 4 line, and this goes, you know. So let's do it. Now we want all the lines which are parallel to this. So let's make another line. You know, for being parallel, their slope must be equal. And in this line 2x plus 4, 2 is the slope and 4 is the cut on y-axis. So let me make two slides C, and I am writing y equals to mx plus c. Now you can see here, and let me copy the properties. Okay. This is my line. Let me change its color again so that it is distinguishable, and I'm making it red. Okay. The black one is my original line. Okay. The black one is original line. Okay. Now what we can do, when I change the slope m, you see this, y equals to mx plus c. In this, if I only value, okay, this is a y equals to mx. When I am changing the m, you will see this plus c is 1, same constant. So this is going from y-axis at 1. This will not change. See, when I am changing m, this is not changing. 1 is constant. So the point of intersection of it with y-axis is constant. Okay. Now let's keep the m constant. And now I am changing y, c plus c. What is happening? M is constant, and as the plus c, you can see this is changing. The line is moving upward. As it is increasing, the line is moving upward. And as see this, you can see, and if it is cutting y-axis at 5, so this point is plus 5. Okay, so this is done. Now I want this line to be parallel to this. I will do it when I do the slope as 2. Now you will see, and I am changing it. Now see this. Now see, the slope of this line is, this is my original line y equals to 2x plus 4, and this is my required line y equal to 2x. When I did the slope equal to x, here it is also x, then they are parallel to each other, because the slope tells the angle from the x-axis, positive side of x-axis. If two lines are parallel, it means they are making the same angle from positive side of x-axis. So I keep the two constant. Now when I am changing the c, these are parallel to each other. Okay, you can see this. You can see these lines are parallel to each other. Okay, now let me show you an interesting animation, and I'm changing it from -50 -50 to plus 50. Okay, now see this. Now you can see these two lines. He's saying that give me the set of all points which are parallel to my given line. So you can say when I am changing C, all lines I am getting, they are parallel to the given line. They are parallel because the slope is same. So in that set, I will say that in that set, all lines of form, see M is constant but C is varying. So all lines of format y equals to m, y equals to 2x, 2 must be constant, y equals to 2x plus c, c can vary, so y equal to 2x plus c, all lines of type y equal to 2x plus c will be related to my given black color line. They are, because they are parallel to it. I hope it is clear to you. Okay, now let's go back to our question. Let's do the next question. Okay, let's go. So this we did in our GeoGebra, and this GeoGebra is complete, and now we will do what we do. Now let's do the 14th question. What 14th question says? What is now let's do the 15th question. Okay, what is 15th question saying? Let's see. This is a MCQ. Let me read it. Let's do the 15th question, and let R be the relation in set 1, 2, 3, 4. This is the set given by R equals to 1, 2, 2, 2, 1, 1, 4, 4, this 1, 3, 3, 3 and 3, 2. This is the given relation. Okay. Now choose the correct answer. Okay, this is set relation, this is set. R is reflexive, symmetric but not transitive. There is second, R is reflexive, transitive but not symmetric. R is symmetric, transitive but not reflexive, and R is equivalence relation. Fourth option means it is symmetric, reflexive and transitive. Now let's check for reflexive. For being reflexive, if 1 is there, 1, 1 must be there, it is there, very good. For 2, 2, 2 must be there, very good. For 3, 3, 3 must be there, and 4, 4 must be there. So this relation is reflexive. This is, I am confirmed about this, that this relation given by this on set A is reflexive. So I can check the options which are denying this. Option C is saying that this relation is not reflexive. Be careful when you are attempting MCQ in exam. It is good that you are searching for correct answer, but many times if you are getting some answer that this is definitely correct, cut this. This will increase the probability of your answer to be correct. Now let's check for symmetric. This is symmetric or not? Let's check from first question. 1, 2 is there. First element 1, 2 is there, but its reverse image 2, 1 is, you can't see it here. 2, 1 is not here. It should be the symmetric image. So this is not belongs to R. Hence it is very clear that this relation is not symmetric. Now we can check that this is satisfying. Now let's check for 1 comma 3. 1 comma 3 is there, but 3 comma 1 is not in the relation, and so this is not symmetric. This, now I am clear that this relation is not symmetric, so I can check for those options which are saying that this is symmetric. You see, first option is saying that this is symmetric, so this can't be correct, remove this. The last one is saying this is equivalence, which it is including symmetric, but our relation is not symmetric, so this option is also incorrect. You can see with only these two I have removed 3 options, and it is very clear that option 2 is correct. So many times when you are attempting MCQs in competitive exams, or when you are preparing for JEE or some other exams, or in our CBSE board exam, take care of this. If you are search for correct answer, very good, but if you have available information, if you can cut some option, definitely this is definitely wrong, cut that, but we will check for transitivity so that we can confirm our answer is correct or not. Let's check for transitivity. Now we will see that here we have 1 comma 2 is there, and the part 2 comma 2 is there, so there is no other pair which start with 2. So then 2 comma 2, 1 comma 4 comma 4. Now we'll see 1 comma 3 is there and 3 comma 2 is there. The first and third element 1 comma 2 must be there, and we have that. So we can do, we can't match any other pairs. So this is transitive. Now you will see second part, it is reflexive, symmetric, but not symmetric and transitive. So this second part is correct. Now let's do the 16th question quickly. What it says, it is saying that let me read the question first. Let R be the relation in the set N given by R equals to A comma B such that A equals to B minus 2, B is greater than 6. चूज द करेक्ट आंसर. उसने आपको रिलेशन दिया है सारे नेचुरल नंबर. सेट क्या है? सारे नेचुरल नंबर. सेट एन ऑफ ऑल नेचुरल नंबर्स. एंड रिलेशन इज गिवन बाय a कॉमा b सच दैट a इक्वल्स टू b माइनस 2. ये रिलेशन है. रिलेशन के अंदर तब आएंगे जब वो इस इक्वेशन को सेटिस्फाई करेंगे. एंड b मस्ट बी ग्रेटर देन 6. डन. नाउ चूज द करेक्ट. आपको चूज करना है कौन सा उसको बिलोंग करता है. Let me write the relation a such that a comma b such that a equals to b minus 2 and b greater than 6. Let's make a table to get this relation in tabular form. For value of 6 it can be 7, 8, 9, 10, 11, 12 and so on, and all natural numbers. What will be the values of a? A equals to b minus 2, so it will be 5, 6, 7, 8, 9, 10. And for b equals to 7, you can calculate b minus 2, that is 7 minus 2. It is 5. For b equals to 8, you can calculate 8 minus 2, it is 6 and so on. We have calculated these values, and so in this way we can have all the pairs. And now let's write this. We can have the pairs 2, 7, 5, 8, 6. We can have the relation in tabular form. Now let's check. Can you see 2, 4 is in this? No. So this is not correct. 3, 8 is there? No, it is not, so it is not correct. 6, 8 is there? Yes, it is correct. And 8, 7 is not there. No, 8, 7. So this is not correct. Hence it is very clear that third part, option C is clear. I hope this is our exercise done, and I hope this is clear to you. If you have any query, you can ask in comments. And we have done with our first exercise, and I hope it must be clear. The concepts are very important, very useful in life, and you can have seen the connection between these concepts of relations and in mathematical terms and real life. The term relation is same, but just mathematics is taking that relation in logical form, in concrete form, in its